So 6.2, we're going to be looking at the algebra and the trigonometric functions. Okay, that means like how do we multiply trig functions together? How do we combine trigonometric functions involved in expressions? All right. So those are the things that we want to look at in the first part. And then the second part is like we want to review a little bit on basic identity and then try to use the identity to simplify. So for example number 1 is basically doing indicated performing indicated operations. So example number 1, the operation is 10 sine squared theta cosine squared theta plus 4 sine squared theta cosine theta minus 4 times sine theta cosine theta quantity square. So the first step that I'm going to do is I'm going to try to rewrite this last term. So this will become time, right? So this is what I got after simplifying the last term, right? 16 sine squared theta cosine squared theta. And then from here, combining like terms. So the first term and the third term is the same, right? Like terms. So therefore, when I combine the coefficients, that will be -6 sine squared theta cosine squared theta plus 4 sine squared theta cosine theta. And this will be the simplest form that I can go so far. So example number 2 is 3 minus 2 secant quantity square. So you are basically binomial square, right? So what you can do is you can use the formula that we learned in a algebra, which is first minus last square. That will be first square minus 2 times first time last plus last square. So applying that, first square 3 square will be 9 minus first time last, so 2 times 3 is 6 secant theta, and then double it, which is going to become 12 secant theta, and then plus last square, which is 2 secant squared. That will give me what? 4 secant squared theta, and that will be my final answer for this example. So example number 3 is simply like, combining these two fractions. So as we know, combining fractions, we need to have a least common denominator. In this case, the least common denominator will be sine of phi times with cosine of phi. So for the first fractions, I'm missing the cosine of phi, so it will be 1 time cosine of phi. And then minus, on the second fractions, we are missing sine, so it will be 3 times sine of phi. So therefore, my final answer is cosine phi minus 3 times sine of phi all over sine of phi times with cosine phi. And this will be my final answer because I cannot simplify any further. Is there any questions? So example 4 is asking us to factor this expression, sine to the 4th power theta and plus sine theta times with cosine to the 3rd power theta. So first we're going to factor out the greatest common factor, which is sine theta, and that will left with sine to the 3rd theta plus cosine cotangent to the 3rd theta. Now this is sum of 2 cubes, so when we factor sum of 2 cubes, right, that will give me sine of theta plus cotangent of theta, and then the next factor is sine squared theta minus sine theta cotangent theta plus cotangent squared theta, and that's basically the factor of sum of 2 cubes. So this concludes this example. So for this problem, right? For this problem, what we need to do is we need to be able to see, as in algebra, factor by grouping. Notice that the first 3 term is a perfect square trinomial. So when I factor this, this will become sine theta plus 3 quantity square minus secant squared theta. Now it becomes difference of 2 square, so I can use the difference of 2 square formula first minus last, and then first plus last, using the difference of two square formula. So if you want to simplify further, you can just take it off the parentheses inside. It's not going to change anything, so therefore this is the final answer for this example. So example 6 is giving to you that alpha is a acute angle. So I'm right here in a right triangle. I've drawn a acute angle. Right? And giving to you the secant alpha is 7/3. And then we want to find out sine of alpha and cosine of alpha. So basically asking you like, two of the 6 trigonometric function with the given informations right here. So secant is basically, hypotenuse over adjacent. So therefore, I'll be using Pythagorean theorem to be able to find out what is my A is. So it'll be A squared plus 3 squared equal to 7 squared. So A squared plus 9 is equal to 49. So my A squared is equal to 40, which will become A is 2 square root of 10. Right? So now when I simplify, after I simplify it, take a square root and simplify it, this is what I get. So now that I know the A value, I can talk about sine. Sine is basically opposite over hypotenuse, which is going to be 2 square root of 10 over 7. And then cotangent is basically adjacent over opposite. So it'll be 3 over 2 square root of 10. And you can rationalize it on the second part, but if you don't, that's fine with me. Is there any questions before I move any further? So the second part of this section is to review on the basic right triangle identity. Right? The first one is a Pythagorean triplet, which is sine squared plus cosine squared equal to 1. And tangent is basically a ratio of sine and cosine, which is sine theta over cosine theta is equal to tangent theta. And then we have a complementary, property, which is sine of 90 degree minus theta is equal to cosine of theta. And cosine of 90 degree minus theta is equal to sine of theta, which we talk about in 6.1. Remember that I shows you on the exact value, cosine of 30 degree is equal to sine of 60 degree, which is using this property right there. Okay. And the other ones are reciprocal identity, which is cosecant theta is 1 over sine theta, and secant theta is 1 over cosine theta, and cotangent theta is 1 over tangent theta. Or another way that you can see is this is also right talking about reciprocal of number 2 identity, which is cotangent theta is also can be looked at as cosine theta over what? Sine theta. Right? So that can be done also. So the example number 7 is basically you want to rewrite everything in terms of sine and cosine, and then what? Simplify the expression, right? So we want to simplify it, but making sure that everything is in terms of sine and cosine. So by saying that the first part is okay because the first fraction is already in terms of sine and cosine. And the second fraction is the one that we need to switch around, which is tangent, that will be able to rewrite as the ratio of sine and cosine, which is sine t over cosine t, plus secant t is basically same thing as saying 1 over cosine t. And the good thing is because of both of them in the two fractions in the denominator, they have least common denominator, so I can basically rewrite it as 1 minus sine t over cosine t minus 1 over sine t plus 1 over cosine t. Now, to simplify this second term, complex fractions, I basically multiply by reciprocal of the denominator, and this will give us. So, after multiplying by reciprocal of the denominator, that's what we got, cosine t over sine t. Now, what we're gonna do is, we can basically combine these two fractions together, but we need to find out the least common denominator. So like before, the least common denominator in this case will be cosine t times with sine t plus 1. So on the first term, I originally have 1 minus sine t. Now I need to multiply by sine t plus 1. And then on the second fractions, originally I have cosine t. Now I need to multiply by another cosine t to get LCD. So simplifying this, and this will be difference of 2 squared that I can use, right? And then cosine times cosine is cosine t squared, and then which give us. So using the difference of 2 squared to multiply it out, and that gives me 1 minus sine squared t minus, and then cosine t times cosine t cosine squared t. Now what we can do is we can basically use the identity, right, to look at this portion 1 minus sine squared t, because we know that sine squared t plus cosine squared t equal to 1. So therefore cosine squared t, that is equal to 1 minus sine squared t. So don't just stop on this identity. You can move around the terms and then get another identity out of it. So you can see now that 1 minus sine squared t basically is what? Cosine squared t. So for this part, for the first two term right here, I'm going to replace with, using the identity, I'm going to replace with cosine squared t minus cosine squared t. And then in the denominator, cosine t times with sine t plus 1. So which will give us, on the numerator, since you are subtracting it, it will become 0 divided by cosine t sine t plus 1. Any number, 0 divided by any number is 0, so my final answer is 0 for this problem. Is there any questions? So example number 8 is the same thing. Wants to, rewrite in terms of sine and cosine and simplify the expressions. So first up, I'm gonna rewrite as 1 over secant squared as a reciprocal function 1 over cosine squared theta, and then times with 1 plus tangent squared theta. That is basically what is going to be sine squared theta over cosine squared theta. Right. So from here, next time when you see this expression 1 over secant squared theta, you should right away know that that will be equivalent of saying what? Cosine squared theta, so that you don't have to write down this step anymore. So from here, that will be cosine squared theta times with 1 plus sine squared theta over cosine squared theta. And when I distribute it, this will become cosine squared theta plus, and then cosine squared and cosine squared cancels it out. It will be sine squared theta, in which this is identity that is equal to 1. And this is basically the final answer of this example. So simplifying this, expressions, 1 minus cotangent squared theta plus over 1 plus cotangent squared theta. For this one, probably what we can do is we can rewrite everything into sine and cosine. That's one easy way to do it. Okay, and from there on, you can basically try to simplify. Right. So from here, that will be, I can rewrite it as 1 minus, right? Cotangent is basically cosine squared theta over, right, sine squared theta. Or if you want to use tangent, that's perfectly fine as well. Okay, so there are many ways to approach these trigonometric problem to simplify it, depending on what identity you want to use. Right. So right now I'm using sine and cosine. So from this complex fractions, what I can do is I can multiply both top and bottom by sine squared theta. All right. So this will give me 1 times sine squared theta is sine squared theta minus cosine squared theta over sine squared theta times sine squared theta. That will give me cosine squared theta. And in the denominator, it will be sine squared theta plus cosine squared theta, and which will give us, this will become sine squared theta minus cosine squared theta over 1. And I will leave it as sine squared theta minus cosine squared theta as of end of this. And of course, if you remember the double angle formula already, this can be continued simplifying it. So what I pointed out earlier is basically if you factor out the negative from this answer that we stopped, then you will get an expression cosine squared theta minus sine squared theta, which is one of the equivalent identity for the double angle of cosine 2 theta. So you need to see, you need to remember the identity first so that you will be able to see what you need to do to get into identity format and then rewrite it. So which answer is the correct and final answer? I would say both of them, if you don't need to simplify any further.